Hi, everyone. Thanks for joining us. Dion Rossiter here from Science at Cal. I am joined with my co-host, Rosalind Sarvey. Hi, Rosalind.
Hi, Dee. Hi, everyone.
Where is the coolest place somebody's tuning in from? I think that this might be a special one since we are talking about Oakland. Maybe we have more Bay Area folks here today.
We do. Yes, I see a lot of folks from the Bay Area, Oakland, Albany, Berkeley as well. So lots of local folks tonight.
Oh, good. That's good, right? Local topic, local folks. Well, we are talking about the Oakland EcoBlock with Sascha, or Alexandra von Meier. She's an adjunct professor in the Department of Electrical Engineering and Computer Sciences and the director of the Electric Grid Research at California Institute of Energy and the Environment. This is our actual last Science at Cal lecture for the spring series. We go ahead and get started in the with our summer programming. Next month, we have one lecture. We'll talk more about that. But before we get started, actually, I'm kind of jumping ahead here. Before we get started, of course, we want to do what we do every day and every time we host a lecture. And we want to actually just do an acknowledgement of the land that we sit on. So we recognize that Berkeley sits on the Huichin territory of the ancestral and unceded land of the Ohlone people, the successors of the historic and sovereign Verona Band of Alameda County. This land was and continues to be of great importance to the Ohlone tribe and other familiar descendants of the Verona Band. Every member of the Berkeley community has and continues to benefit from the use and occupation of this land since the institution's founding in 1868. Of course, your beautiful faces are blocking the screen, so I can't read. Whoop, one more. By offering this land acknowledgement, the Berkeley community not only recognizes the history of the land on which we stand, but also recognizes that the Ohlone people are alive and flourishing members of the Berkeley and broader Bay Area communities today. And again, I think it's incredibly relevant since we are talking about the local environment. So again, thank you for allowing me to give that land acknowledgement. If you are new to Science at Cal, welcome. If you are here again because you are a dedicated viewer, welcome back. Science at Cal celebrates science. We bring the wonder and excitement of UC Berkeley STEM research to the community, and we have been doing that for quite a number of years, since 2009. All of our events and public programs are free, geared towards public audiences. We're so excited to have you. Like I said, I kind of jumped ahead. We have so much programming coming up. We're excited to hopefully see the end of shelter in place soon. We offer science cafes, lectures, festivals. We are at all of our Cal Day events, campus partners. We partner with consulates, libraries, everything you see here, First Fridays, farmers markets, community centers, artists, you name it, we've been there. We can't wait to get back into the community again sometime soon. Like I said, we do have a bunch of summer programming heading into a new season. So June, July, August, we have, we noticed that we actually, once we started up our lectures back in the virtual format, we have not had a single programming on COVID. Isn't that interesting? So we actually are diving into COVID kind of a year and a half in. So we'll be hosting somebody who's also focusing on the Bay Area and groundwater for COVID research. We have the science of happiness and gratitude. So this is with the director of science at the Greater Good Science Center. We're super excited to have her joining us. And then Earth's Deep Interior in August. So mark your calendar. These are always the fourth Wednesday of the month at 6 p.m. So we look forward to having you there. Our next Grounds for Science is in June. We have 3 more of those coming up. Here's just a few of our topics. Why don't plants get sunburns? And got milk? How can we tell when our mammal ancestors first produced milk? Interesting topics. And of course, our Midday Science Cafe series. We have May, June, July, August, all set up for you. Machine learning, synthetic bio, negative emissions technology, periodic table. We are all over the place, folks. So we have everything ready to go in the next few months. Rosalind, we've got a busy summer ahead of us. So we hope to see you all there. Again, mark those calendar dates. I want to thank you also for supporting Science at Cal. I know some of you have donated or have donated in the past. I know you all are great fans. I know you show up week after week, and we just want to thank you for that. And thank you for being here. And without further ado, I think I'm going to hand it over to our speaker so she can go ahead and, oops, stop share. She can go ahead and take over the screen while I read her bio for you. Oh, before I forget, don't forget you can ask all of your questions in the chat. Please continue to do that. We will get to all of your questions at the end. Please keep yourself muted. We will go ahead and mute yourself mute you if you accidentally become unmuted, but please try to stay muted so Sascha has the floor. Again, at the end of the program, we'll invite you to actually share your screen or share your face and unmute yourself, and you can ask Sascha all the questions that your heart's desire at the end of the program. Also, Rosalind and I will be monitoring the chat. So Sascha, you don't have to do that. No need to pay attention to the chat. We'll be doing that for you. And you can also go ahead and ask questions in the chat, and we will collect those and ask them. If you don't feel comfortable unmuting yourself, that's totally fine. So again, I will go ahead and introduce Sascha. So Alexandra, or Sascha Van Meier, is an adjunct professor in the Department of Electrical Engineering and Computer Science. I'm going to bring your profile so that I can actually read it. Now I don't know where it went. Of course, technical difficulties. We've had them a few times, haven't we? All right.
Luckily, it says it all on the slide.
And now it's on me. Oh, it says it all there. Well, I'm going to give a little bit more information. Electrical engineering and computer science at UC Berkeley. Of course, we know that. And she directs the electric grid research program at the California Institute of Energy and Environment, or CIEE. She is also a faculty scientist at Lawrence Berkeley National Laboratory. And actually, I've seen her speak before at Berkeley Lab, which is why I invited her. I thought she was absolutely fabulous. So excited to have her here. Her research focuses on the power distribution system, including the application of novel sensing, analytics, and control strategies to facilitate the integration of distributed energy resources. I'm guessing that's what she's talking about today, so you'll learn more about what that all means. She is the author of a textbook, Electric Power Systems, a Conceptual Introduction. And Sascha was previously professor of Energy Management and Design in the Department of Environmental Studies and Planning at Sonoma State University. She holds a BA in Physics and a PhD in Energy and Resources from our very own UC Berkeley. So go Bears, we cannot miss that cue. So thank you so much for being here. We're so excited to hear you speak about the Oakland EcoBlock. So thank you, Sascha, and go ahead and take it away.
Thank you, Dee. How's my audio right now? Does this work?
Yeah, you sound wonderful.
Awesome. Thank you so much. It's such a pleasure to be here. So I serve as the principal investigator for the Oakland EcoBlock project. And I have the privilege of sharing with you what's really the work of a big Berkeley team. I'm not going to go through introducing everyone, but it's a very collaborative effort across a lot of different disciplines, and also between the Berkeley campus and the Berkeley Lab and other organizations in the public and private sectors. So please come visit our ecoblock.berkeley.edu website, and you can read more about our whole team. So I want to start with the big picture, the big challenge: climate resilience and equity. Climate change really is the defining problem of our time. It's an existential problem, and very seriously, that means that if we don't deal with it and we don't get it right, then all the other science we do may not matter, because humanity may find itself in such a predicament. This is really absolutely urgent and essential. And we need to both limit climate change as much as possible, and at the same time face the reality that there's already some change we are irrevocably committed to. And we have to address how that impacts real people, how it impacts people differently, and how we can help communities cope with those impacts and with those challenges ahead. So those are the three motivational pillars for the EcoBlock project: climate resilience and equity. I want to quote John Holdren, former Berkeley professor, science advisor for President Obama. And the way he put it was, we have to manage the unavoidable and avoid the unmanageable. So energy plays a crucial role in this. It's not the only sector involved, right? Agriculture and land use are really important areas of human activity impacting climate. But of course, carbon dioxide is a leading greenhouse gas along with methane, and we have to remove them both. So decarbonizing the energy sector involves very specific steps. Number one, efficiency. We have to not waste energy. And that actually helps our economy to operate more efficiently, do more with less. Secondly, adding clean renewables. So our California state goals and the new goals from the Biden administration are ambitious. I think they're reachable, but we've got to give it all we got. Some of the most economical solar and wind power will probably come from large solar and wind farms that unfortunately are in the less populated areas. And I think that needs to be augmented with smaller scale local resources, which are going to be there in case the grid fails. And those need to be integrated properly and thoughtfully. We also have to deploy energy storage to smooth out the inevitable variations in the availability of solar and wind. And then we also need to transition fossil fuel end uses over to clean electricity, because that is very likely faster, easier, and less expensive to do than to replace them with biofuels for most applications, including transportation, so electric cars, trucks, rail, and also in the home, shifting over to electric heating and electric cooking. Now, resilience means being able to deal with crises and recover from them. And then equity, of course, means that ensuring that everyone has access to the benefits of advanced and clean technology, clean, reliable energy, and that includes those who've in the past and still today are carrying the brunt of the impacts of our legacy energy systems, in particular with air pollution. But also health impacts in the home. Really, equity is about everyone having the opportunity to be safe and healthy in their home and wherever they go, including being comfortable during extreme weather. So what we know now is that extreme weather is real. We've seen this with droughts, wildfires, hurricanes, and most recently with this cold event in Texas. That we have to be prepared for weather statistics to change. So this is not just about some average change over time, but the extremes, right? The variance in the distribution is changing, which makes it, for instance, very difficult to calculate how much insurance you should take out for different things. That was a problem in Texas when the power went out for millions of people for days on end because they couldn't produce natural gas, they couldn't produce enough electricity. More than 100 people died in that storm, including some from hypothermia indoors, some from carbon monoxide poisoning because they tried so desperately to stay warm indoors, they left their car running in the garage. We look at this and say, well, the power plants and production facilities should have been winterized. They should have bought insurance. But that winterization, interestingly, applies to homes as well, right? Because well-insulated homes would have made that event much more bearable and survivable, even if the power did go out. The fact of the matter is that besides crazy weather, there's other things that can bring down the electric grid, from solar storms to earthquakes, cyber attacks, which we know are lurking out there. So when we talk about resilience, it's really understanding that we don't just have to reinforce the electric grid to make it more reliable. We need to do that too. But we can't increase the reliability to an absolute 100%. So first and foremost, we have a responsibility to make sure people's basic needs are met, even when the grid fails, so that people can stay safe and sound. So that is really that relates very much to an integrated design problem of sustainability, because making places more environmentally sustainable and healthier relates also, again, to how we produce energy, how we decarbonize that energy, and it cuts across all these different disciplines: energy, water, transportation, how people work together, and how we pay for new investments in clean technology so that we can capture the benefits for all of the parties involved. Our hypothesis with this EcoBlock project is that you get the most bang for the buck when you address these components together rather than individually. We also suspect that there's an economy of scale. And this is an interesting thing because on the one hand, things get cheaper when you make fewer of them and make them bigger. But on the other hand, things also get more complicated. If you go to a larger scale, it can be more daunting. So the hypothesis here is that there's a sweet spot around the level of a block or a neighborhood where people can actually get to know each other and work together and do something very concrete that fits their local circumstances. Now, I expect that there will be many dollars of federal investment, like we've been reading in the news, that will actually be targeting these areas of climate resilience and equity. And the question will be, how do you spend those funds most effectively to get the most value out of them for the most people? When it comes to meeting our climate goals, we can't afford the time to wait, for instance, to turn over all the housing stock and build all new buildings, right? We need to work with what we've got. So that's kind of the background and motivation for the EcoBlock Approach, which is a project funded by the California Energy Commission, with the goal of coming up with a standardized, almost cookie cutter solution to the problem of how do you transform a city block in all those dimensions that we described, where a city block is several tens of homes, right? So that means getting into those homes and doing upgrades for water and energy efficiency, putting in new wall insulation, efficient appliances, new water fixtures, replacing gas furnaces with highly efficient electric heat pumps, replacing gas stoves with efficient induction cooking, and of course, LED lighting. Then we use all the available roof space from the various buildings, and some will be better than others, for shared solar panels. And we take advantage of the fact that we can use the best southern exposure where there aren't trees. We add battery storage and retrofit the whole electrical infrastructure to turn the block into a microgrid that can operate independently when the main grid is out. We add intelligent controls so that people can prioritize what's most important. If they do have to cut back during an islanding event, they can prioritize what they really need and what maybe they don't need, depending on the state of charge of the battery, depending on how long they expect the grid to be out. And the really innovative idea here is that these assets are owned communally, that the ability to create the microgrid is more than one household could realistically do on their own. It's worth pointing out that most of the PV that's installed today does not have that capability, because you just pay extra for having a battery or for having an inverter that can function either as a grid following or a grid forming inverter. So in a disaster scenario, the reality is that most of the rooftop solar that you see installed is going to be useless. And that, you know, is one thing if we're talking about an inconvenience for a few hours, and it's another when it turns into a life or death situation. So we think that by creating this framework that makes it easy to participate and for multiple households to share in these assets, it will become more affordable. Not everybody's going to hire a contractor to do a whole makeover for their house and get a power wall. And also people don't necessarily have the time to educate themselves about exactly what all they want. So the standardization and making it easy to participate is a really important piece of this. And we think ultimately it will be faster on the national and global scale to retrofit existing homes block by block rather than doing it home by home. So I'd like to speak a little bit more to this point about the economies of scale. We actually did some simulations on this. It's not just that 100 kilowatt battery is cheaper than 25 kilowatt batteries. It's also about taking advantage of the load diversity when you share resources. So these are just some sample results to kind of visually illustrate this. We asked the question, what fraction of your electric demand or load can you serve continually based on a given amount of solar PV and battery resource that you install? And how does this change when you aggregate more homes together? So that's this, I don't know if you can see my cursor, but on the horizontal scale here, it's the number of homes in a power island. And so in this case here on the left, we size the solar to meet 65% of the load and the battery to meet 8 hours worth of average load, and ask the question, what happens when the grid suddenly goes out at some random time? And depending on the season and the weather and that particular day, we have some chance of needing some fraction of the load here on the vertical scale, with the probabilities indicated with the shades of blue. Now, with a single home, we're very sure that you can meet 20% of your load, but that may not be enough. There's a decent chance we'll get, 40 to 60% of the load. But as we combine more homes, moving to the right here, the statistics start to work in our favor, and we get this narrower distribution, so we can have a lot more confidence in how much of our load we'll be able to serve. And so that means we can actually design the system for the amount of load that we know will be essential, will be necessary, which would be too risky to do for an individual home. So by aggregating homes on the block scale, you gain this diversity factor. If you go to more than 20 homes, so if you aggregate multiple blocks, you don't really gain anything further from that. The other case on the right, same idea, but just with a more generous sizing of the solar resource and the storage capacity, you see the same effect that once you aggregate several homes, you do better. So the takeaway is there's a benefit to sharing. We can make do with a more modest investment per home than if we did it individually. And besides that, you're going to save on the engineering, the permitting, all those transaction costs of actually getting a job done. So you see here logos of many of our partners. Again, they include engineering firms, architects, planners, legal experts, financial experts, construction teams. It's a deep bench with strength in numbers for sure. And I want to highlight especially the City of Oakland, who's embraced this EcoBlock approach as one possible way that they can advance their sustainability vision and strategy. So they're working with us on everything that falls under their jurisdiction. For example, looking at how the permitting process for projects like this can be made straightforward while protecting, of course, public interest and safety. And similarly, PG&E is working with our team because honestly, their thinking on microgrids has evolved considerably in recent times, especially with the horrendous wildfires that we've been through. So they're really interested in how they can serve customers even in the cases where they have to turn off transmission lines into an for example. So you might imagine the Sierra foothills, where the PSPS events may unfortunately become business as usual. And PG&E is also working with us on identifying the best tariff for this sort of innovative situation of multiple residents sharing energy with each other. That is a work in progress. I'll show you the approximate location of the EcoBlock in East Oakland. We try not to advertise the exact location to give the participants a little privacy. We selected this block for a number of criteria, partly physical and partly based on the community. We're also happy to, not put this in the most affluent parts of Oakland where there's interest too, but they don't need to be subsidized with ratepayer funds. So we're in a small cul-de-sac off Fruitvale Avenue, a mix of medium and older homes, some single family, some apartments, some commercial properties on the corners. So from a technical standpoint, PG&E sees a good opportunity here to work with a small lateral distribution circuit that can be separated from the main grid at a single point. Also strategically looking into the future, when all of our natural gas uses will have to be electrified and the natural gas pipelines will have to be capped off section by section, this is a place to learn how to do that. It makes sense to start with the legacy low pressure gas system, which is outdated and would at some point have to be replaced. So it's a great candidate to say, let's shift over to electricity and see how that works, see how it works, if we apply subsidies, which may be necessary, working with the actual customers to make this a win for them rather than a loss. The other strategic part of the picture, of course, is anticipating electric cars to meet our mandates in California, especially. So that may necessitate upgrades of distribution transformers and such. So our hypothesis here is that by combining these distributed resources and coordinating them together into a single package, that will make the overall transition less expensive and smoother, and perhaps also more equitable. So sounds great, easier said than done, right? What's, I think, hardest about this model is that it really hinges on cooperation and trust. There's a lot of entities that have to work together: solar developers, the utility company, landlords and tenants, who will each be looking at different incentives. Forming a self-governed community association, the neighbors their interests will be protected in some formal and legal way. But for starters, especially when you're doing this the first time and we can't yet point to an example of where this has been done, we need a certain degree of good faith and trust to start with. So we know this is hard because others are trying this also. The California Energy Commission, out of their electric programs investment charge, or EPIC program, they funded, under the title Accelerating the Deployment of Advanced Energy Communities, 12 projects in a phase 1 that was more exploratory and theoretical. There are now 4 of our projects you see here on the map funded for phase 2. And really, the idea with phase 1 was to do a proof of concept to show that a design would be plausible and to do some modeling. In the abstract, phase 2 is let's actually build this. And so a lot of things actually have already changed from our initial design plans to the execution. We've recruited a block. We have now a very site-specific design. We started in 2019. We're a little bit behind schedule, not too much due to COVID, but we've now done some detailed analysis for this block, and we're set to start construction this year, fingers crossed. And the project runs until 2023, at which point we hope to have really good performance data that basically will tell us what worked and what didn't, and how would we do the next block and the next 10 blocks or the next 100 blocks. I mentioned this is a really multidisciplinary endeavor. So we combine energy, water, mobility, urban planning, community, and then the legal and business and financial aspect is really important, because we have to think already about how is this going to pencil out when you don't have $5 million in Energy Commission funding, when it has to pencil out as a grassroots effort. So let me show you a little bit of update about the work in progress. We have 33 participating units on the block. We've been able to do the in-home assessments in a COVID-safe manner with the right precautions, and are planning to start the physical retrofits and new appliances this year. And the participants will be able to choose from a short list of options that will be funded, in this case by the commission. In the meantime, our water team has been getting to work on the outdoor side, working with the runoff and optimizing the rainwater flows and the runoff into the creek nearby. And then the microgrid construction, we hope to start this year as well. We need to finalize our interconnection agreement with PG&E, which has been an interesting process of really looking carefully at all the details and the different options. In fact, we've departed quite a bit from the phase 1 design, which had envisioned a separate standalone direct current, or DC, infrastructure. Given PG&E's interest, which is greater now than it was years ago, we've decided that a collaboration really is the least cost and probably the most scalable approach. So working with PG&E, using their existing AC infrastructure that they continue to own and operate, saves a lot of money, not just on the construction, but also on insurance that the EcoBlock would otherwise have to carry if they, if the block, the community association hires a contractor to operate and maintain that infrastructure, and then to insure it. That's a whole, other challenge. Future EcoBlocks may avail themselves of that option, but we think it's actually a great option to see what we can do, again, in the spirit of retrofitting, using as much of the existing infrastructure as we can. So the solar PV is going to be spread out across the rooftops according to whatever is the best technical fit. We plan to have curbside EV chargers where the block members can have access to an EV that's powered by the microgrid, even during an emergency. So there's a lot of detailed design questions that are fascinating to me as an electrical engineer. I won't get into, unless people want to, in the Q&A. But there's, pros and cons about doing things different ways. How do you distribute the battery capacity in one place or at multiple homes? Where do you connect things relative to the existing meters? Do we isolate the microgrid island on the primary or the secondary voltage side? And a key deliverable for the project actually is an EcoBlock handbook that details not just how we ended up doing things for this block, but all the pros and cons and the deliberations of what might work better in one place or another, depending on the situation. So the way we're doing it here wouldn't necessarily be the way that you would do it everywhere. Now, the most important part of this whole adventure is the people, right? And we actually started with a community outreach specialist whose job it is to know everyone, understand people's perspective, and who coordinated the announcements and self-nominations that we received from blocks who wanted to be considered for this. Really, the block we're working with was outstanding in terms of their ability to self-organize, and having some level, I mean, there's a lot of unknowns here, and some level of confidence and trust and spirit of adventure that we will make this work for them. But it's also a matter of listening to concerns that maybe we wouldn't have come up with, like the parking spaces on the street, or what do you do design-wise to discourage crime on the street? There's 6 languages spoken on the block. We've had translators for some of our meetings. We've held outdoors, COVID-safe in-person meetings and some on Zoom. And we really get to address all the classic problems in economics and behavior about how you create the right incentives for the different participants, in particular, property owners and renters. Everyone's got a different stake in this and different concerns. The property owner would make the investment in the energy upgrades, but then the renters would save on the utility bills. How do you negotiate that? So we try to incorporate as much input from the participants as possible. Really, the bottom line is a transparency of process so that everyone understands why certain choices were made. And we need to make sure that after 2023, when the research team walks away, the block has a governance process where they can make decisions together, like, what happens when someone sells their house, or one of the neighbors who didn't initially opt in changes their mind. And we actually have a professional facilitator to help the block create a community organization with a steering committee. So, speaking a little bit more to the economic, legal and regulatory challenges here. As I said, first of all, we have to think about how will this pencil out when you don't have research funding. There may be other forms of subsidy available. I think very likely there will be, but how do you leverage that into a project like this efficiently? So we have to have an efficient mechanism for the community to come together that allows them to share the ownership, share the responsibility, and obtain financing. There has to be protection for all of the participants, make sure nobody can get taken advantage of, but at the same time, operating on a foundation of trust. Then there's this whole other interesting set of legal issues about multi-customer microgrids, which are very novel. There's a well-known over-the-fence rule that says you can't just sell electricity over the fence to your neighbor. That would make you a utility. There would be a lot of safety concerns, as well as the utilities' concern about their monopoly. Now, in our particular approach here for this Oakland pilot block, we don't run into this issue because in our design, PG&E will actually continue to own and operate all the wires. But future EcoBlocks may want to install their own DC wires to leverage that efficiency. For example, feeding power from a solar panel on one property over to the battery that happens to be across the property boundary next door, right? So it turns out, well, if I'm a big property owner and renting out different buildings to different tenants, I'm at liberty to connect them with a microgrid. It's very straightforward for a single entity, like a corporate campus or university campus, to build a microgrid on their property. But we think that should also apply to the little guy, to multiple small parcels if they aggregate together into a community entity with shared ownership. Because we're not talking about selling electricity for profit, but sharing in a resource that unlocks the access to the economies of scale. I like the analogy of a wheel of cheese, right? Suppose there's this great cheese, but you can only buy it as a wheel. So my neighbors and I, we all chip in together and we buy this big wheel of cheese, and then we slice it up and we each get a piece that we couldn't otherwise had. That's not the same as opening a cheese shop. So these issues are being very actively discussed right now at the California Public Utilities Commission, because our state policy goals really on climate and resilience are driving us in this direction for leveraging microgrids. So people are thinking about this hard. There's a lot of good discussion going on, and I think we'll see a lot of evolution on this in the coming years. So once we complete this pilot EcoBlock as an example that we can then point to and see what to do and what not to do, I think there's a really exciting future ahead for community microgrids. Our scope includes thinking about, the design aspects of what could stay the same, what might be different for other blocks depending on their situation. Once we have enough of a template or recipe, then other parties will be able to come in. I can envision, nonprofits that could specialize in helping neighborhoods organize themselves, navigate the legal aspects, connect the community with financing or public funding opportunities to advance climate resilience and equity, to make sure that funding gets put to the most effective use. And we think that because a city block is a recurring unit of organization, that offers the opportunity for very rapid scaling and replication. So that gives me personally a lot of hope. I think I will stop here for questions.
Awesome. You have had a lot coming through the chat. So, so there's plenty to go around. So the first question, well, actually, I'll ask the audience. Thank you. I see you got some claps. We have a hand raised already. So go ahead and raise your hand if you do have a question, and we'll call on you as we see them. So Dale, go ahead and unmute yourself.
I'm curious to know if the electrical grid would be undergrounded during this process, and not necessarily in the pilots, but is it intended to be undergrounded? And what would be the safety considerations taken into account for seismic events?
Great question, right? So, right, for this pilot, we do not expect to be undergrounding the infrastructure. We're looking to do this with a sort of minimalist approach. It will cost some money. There will be some changes, but in the long run, obviously in very fire-prone areas, there's a real benefit to having the electrical infrastructure underground, because it doesn't pose such a risk for fires. I think that gets into a really complicated strategic question, which it's too soon for us to really negotiate, but it's a question about, how much of this type of retrofit would be paid for by the community and how much of it would be rate-based by the utility as part of their regular process of upgrading. And that conversation is not a new one, because it happens in areas where distribution infrastructure is being undergrounded, and sometimes a developer or a community will pay for that. Other times the utility will pay for that. So I think that will be an interesting conversation going forward. In terms of earthquake safety, I'm not sure that there is a huge difference between underground versus overhead. I think that the fire safety is probably front and center. I think at the scale of the individual block, the nature of the infrastructure is sort of less sensitive. There's a much lower probability that your power would go out because of something that's exactly on your block. There's a very high probability your power might go out because of something that's somewhere on your distribution circuit. So by having this block scale, you're actually, I would expect you would vastly increase your reliability. there would be negligible times that an outage would actually occur on the block proper.
Great, thank you. Ifechukwe, do you
Yeah.
want to?
Ifechukwu, hi.
Hi.
This was really cool to listen to, a current UC Berkeley student. Wondering about, you mentioned the issue of inequality in the beginning, and sort of as you got to the end, it became more clear, right? The ways that this could very quickly become very inequitable. And I'm just wondering, from the economic legal standpoint, what are some ways that what are the plans beyond, when the research group is no longer involved, to keep this from being privatized, right? Because it's very much self-fulfilling, where if we're already living in a state of inequality, those who have access to more are able to provide funding, right? You were mentioning the issues around funding, and then sort of get a hold of it, and then it turns into something that, again, becomes controlled by whatever private entity acquires it. So are there any plans for legislation or rules or things in place so that this doesn't become another thing that is just a cool idea owned by a corporate body of some sort, to kind of keep it accessible and keep it community centered in that way?
That's a great point. I would say that I'm actually pretty optimistic that a lot of the programs, the public funding that we've seen that, and that's being talked about, I think is going to be targeted very specifically to communities who could not otherwise do these things. And wealthier communities can self-organize and get financing by themselves easily. And I imagine an effort really to subsidize and enable this kind of initiative in areas that need it most.
Yeah, that was a great question. Thank you. James, how about you? Do you want to go ahead and unmute yourself?
Great, thank you. Can I be heard?
Yeah,
Yes.
you can.
So in part, I'm asking this is about education and public outreach, if there's an element of that. And I must acknowledge that a lot of this has to do with, because this is a Science at Cal event, and Science at Cal is fantastic about education and public outreach out at the farmers markets and events. And we love to be with them. And we're at very large events like the science festivals, Solano Avenue Stroll, and so on. Is there an element of education and public outreach, of course, respecting the privacy of the locations and so on, to look forward to? We're always looking to help great programs engage the public and students in particular. Thank you.
Yes, I'm super excited about the educational part. I mean, in fact, I would say we've started with the block. We have, regular newsletters and tutorials about some of the technical aspects. I think there's opportunities ultimately for workforce training as well, and educating the general public, I think, around the time that we really have results to show. So right now it's wonderful interdisciplinary and social science. And I think when we can point to specific physical results in a year or two will be a great moment, because then, you can take a walk and say, and point to the equipment and say, this is what this does.
Thanks for that shout out, James. So when we head back into the community after shelter in place is lifted and we are at our farmers market, we're going to be calling your scientists to come join us to talk about what you're doing in Oakland. Okay.
That's awesome.
Great. Thanks, James. And Carl, do you want to go ahead and unmute yourself?
Hi, Sascha. It's nice to see you. What, if any, of the new capabilities of the smart residential distribution panels are you using in the pilot project?
I cannot yet answer that definitively because we haven't spec'd the actual equipment. But I will say at the very least, there will be transparency of, what appliances are using how much power, and the ability to prioritize them. There is an interesting problem that has to do really with the measurement aspect, where on the one hand, you want as much granular information as possible to inform, the microgrid controller, as well as sort of reconciling the accounting at the end of the month. And on the other hand, there is kind of a privacy issue where it's like, I have no business knowing at what time of day Mrs. Smith makes toast in the morning, So there are data solutions for dealing with that. And we haven't spec'd out exactly which products we're going to be implementing here. I don't know if that answered your question to your satisfaction.
That's pretty good. I was also thinking about fitting more electric loads onto the existing electric service.
Oh, so great. Thank you. I was thinking about the smart controls and stuff, but just from the standpoint of ampacity, there are some panels that have to be upgraded just to be able to accommodate the amperage for, a heat pump and, all the new electric loads that are switched over from natural gas.
Thank you. I see JPGM also has their hand raised. Go ahead and unmute yourself.
Hi there. Thanks so much for your talk. Sorry I don't get all this technical electrical engineering stuff, but I like the idea of solar panels. Can you give me just a clear thing on if you want your home to be the most useful for climate change and this grid idea? What do I say to the dude at Costco that's offering to do an assessment for solar panels? What would I tell him? I just need the panels, or I need a battery, or I guess that. Sorry if I'm sounding way too dumb.
No, that actually, I like the way you put that question. So, we've always said, well, you start with efficiency. And that was important, especially when solar panels were expensive and when you might not be able to meet all your electric demand with solar panels. I still think, it's prudent not to use more than you need. So I would certainly say any appliances that seem like they're at the end of their life, think very hard about replacing it with something much more efficient. For starters. Now, on the PV side, there's been a lot of convergence, in the design, so it doesn't matter that much what kind you get. As for the battery, that's primarily for right now, the way the tariffs work. It's for the purpose of just ensuring that you will have power when the rest of the grid is down. Now, what I would like to see in the future is that more battery storage will be recruited to very intelligently shape the kind of net demand at a given location. And so that requires having certain financial incentives. And one way that you can use a battery today is simply to take advantage of time of use pricing and sort of shift your load over to when the grid is less congested, let's say, or resources are in more ample supply. So I think the coordination of electric demand and solar production and, the process of charging and discharging batteries, coordinating EV chargers, can, if it's uncoordinated, it can do real harm to the distribution system. If it's well coordinated, it can help power quality and reliability. So, your battery in theory has the capability to help with that. I think we are going to see some evolution of the tariffs and incentives to be more precise about giving people the right signals to do the right thing at the right time.
That was helpful. And actually, he also asked in that same question on the chat, and I had said to Rosalind, oh, I missed that, because what you said was essentially that the rooftop PV is useless, right? In a disaster. Could you give us just a two sentence summary of that one more time about why it's so useless?
Right. So your standard installation is going to have a grid following inverter and no battery. And that is a way that you can take advantage now of net metering tariffs, where basically you reduce your utility bill to near zero by producing your own solar power. So if someone is putting solar on their roof right now with the intention of, hey, this is going to save me money, that would be kind of the way they do it. Now, there are very specific rules and standards for those inverters to disconnect themselves when there's a problem in the grid, and that's for safety reasons. You don't want the grid to be energized by random inverters everywhere when there's, a tree has fallen on a line, utility crews are going to come try and repair it, and there's a real hazard there. So without a battery in your house, the inverter alone won't be able to sort of run all of your lights, all of your appliances properly, right? So it's just a matter of, a vast majority of the solar installations aren't set up for that purpose.
Got it. Okay. Like as soon as you said it, I was like, wait, woo? Like, and then it was.
And I'm concerned that, there may be a day in California where we have a big power outage, and we will be looking at all of that solar resource that's sitting there that can't be used, and wishing that we had set it up in a way where you could operate a block.
Right. In retrospect, it's like, this should have been done this way. Yeah. Rosalind, do you want to ask some questions that have been coming through in the chat? We have a lot.
Yes, lots of activity in the chat. We had one question pretty early on about whether you could summarize why the block level is what you called the sweet spot.
Mm-hmm. So you need some number of homes, like I would say at least 10, to really get the advantage of sharing the resource. It gives you the ability to basically get more for your money, and have energy security with a more modestly sized resource on a per house basis. And also realistically, forming that association will give you access to hiring the engineers and getting the financing and doing that's sort of a little bit challenging for a lot of families to do on their own for their own house. So there is an economy of scale that I think is you get the benefits in that 10 home range. Now, when you get larger than a block, so if you have like more than 20 or 30 homes, it gets to be more complicated because you have more members that you need to sort of govern with and make decisions with. You need to now cross a street, which is okay if it's PG&E doing it, but it's not okay if you want to run your own wires, and it makes the islanding more complicated, probably. You just add more complexity into the mix when you do more than one block. So that's why we think one block, it's like it gets you the advantages, but not the drawbacks.
Thank you, Sascha. We had another question in the chat. We've heard a lot about switching over from gas to electric. Have you gotten a lot of resistance on doing that switch?
No pun intended. No. So I think we have encountered polite skepticism, just as I would be politely skeptical. In particular, induction cooking is like not obvious until you've actually tried it. So our community liaison, Kathy Leonard, she was great because she was talking about how she never would have thought that induction cooking was, something that she would consider. And then she took a class where they actually showed you that you can get really high temperatures And so it's sort of a matter of being accustomed to it. I think on the side of like the heat pump, which is the other somewhat innovative or unfamiliar technology, I think people recognize that there's a real benefit to not burning natural gas indoors. I mean, just thinking about the air quality impacts, the risks of carbon monoxide. So in general, I think people are pretty excited about getting electrical appliances. Now, depending on what the financial model is, it's a lot easier to be excited about something that's free. So what we hope is that those benefits will be, that it will be attractive, and it will be easier to make the decision to, go in on it, take out this loan, get this stuff, when you can go visit a place that already has it. And you can see, well, what would this be like?
That is really good news to hear. It looks like we have another hand raised. Ife Chukwu, do you want to go ahead and unmute yourself again?
Yeah, the second part of the question I had, right, was, of course, like finances and people having access. And you answered the question by mentioning that low-income communities will be prioritized when it comes to public funding. Is this an idea, though, that can just be purchased, by a private body, in the way that I'm a bit of a skeptic when it comes to things around capitalism. And I say this very politely, and so I hope that I'm not offending you by asking this, but is this an idea that a company can just be founded based off of, and then it's like, this is what we do, and if you want access to this because there's a prototype, like, you're gonna have to pay us, and we control who gets it and how much you pay and all of that kind of stuff?
Great question, right? So it is, if I may paraphrase, is there intellectual property here that somebody can take or like patent something and then they're the only provider? I think we have a wonderful tradition at Berkeley to put a lot of our research results into open source formats. There's a lot of open source code that's been developed for instance, control strategies. And the whole modus operandi for our project is to be really transparent. And we're just putting everything out there into the public domain because we want to see it adopted by a lot of other, a lot of other parties. I mean, it's fair to say, hey, look, there are, private companies who are providing cost share and who are participating in this, maybe with a thought that, oh, they'll have a piece of the future market. I also think that all of them recognize that this future market, we want to be very large, and there will be a lot of room for different participants, because there will be different circumstances and conditions that I imagine different players will specialize in. So as for the learnings from the EcoBlock project, those will be very much I think, disseminated publicly with an eye toward, diverse players being able to pick up the parts of the idea that they can specialize in and carry forward in certain locales.
Okay, so in summary, it's going to be just like public information, and people can kind of do with it whatever they wish.
I think that's fair to say, yeah.
And possibly patent.
Yeah, I mean, there's been enough published that nobody can go and patent EcoBlock.
Mm-hmm.
Okay, cool. Thank you. That's clear.
And you have taken considerable steps to ensure that, like, partnering with the groups whose entire purpose is to work with community members, right? And I feel like that's a really important piece, that not many groups will immediately say, okay, how can we do this, and how can we do this effectively, and how can we work with the community before we even get started? And that seems like what you guys have done, right? So
yes, and also, again, I want to highlight the role of the City of Oakland. The City of Oakland is not in this for a profit. They want to see results that create healthy, secure places for people to live.
Mm-hmm, mm-hmm. Go ahead, Rosalind.
Great, thank you. I just wanted to check, JPGM, did you have another question? I saw your hand is raised. I wasn't sure if that was just from the prior question. So I just wanted to give you an opportunity.
Oh, whoops. No, that was it. Thanks.
All right, no worries. Do we have questions from the chat?
Yeah, okay, so I'm going to summarize two questions. One question is, there's folks online here who work in the space of, of building environment, HVACs, those sorts of things, and they want to help. Is there a way that they can get involved in that way? Is there somebody that is connected to the EcoBlock project that they can reach out to? Is that you? Are you even offering opportunities for people to volunteer their services?
So I would say we have all of our boxes filled right now with collaborators, but we are very often meeting new organizations and having conversations about, how to do stuff. So all the time we learn about companies that do cool things in this space where, there may or may not be an opportunity to participate directly in the pilot EcoBlock, but we can at least have a conversation. So there's, the easiest thing to do. You can email me, you can email Therese Peffer, the project manager. Easiest thing to do is just to send an email from the website, the contact, because we have someone monitoring that and then they'll route it to the right person.
Perfect. Okay, then the next question that I'm going to summarize is in terms of students possibly getting involved in a type of citizen science project where they're helping or learning about the monitoring, since there's so much monitoring that's going on at a really micro scale, house by house, time by time. Can students kind of tap into that? Or has there been ideas on how they might be able to do that to create a learning opportunity there? I'm not even sure as UC Berkeley, our students, are they using any of this? And are there plans?
Well, we have a lot of students actually working in different functions with the project right now. And again, for anyone who's interested in collaborating in whatever way, I would say, shoot us an email. Tell us who you are and what you love to do.
I love that. You're so welcoming. So are there specific links to the Utilities Commission proceedings on this so that people can read more about it there?
Great question. I'm actually not sure right now where on our website we have those or which ones we have. They've been holding, bi-weekly meetings with the working group, and there's, I guess there's not really documentation from that specifically, but there are all the, as a matter of public record, all the comments that have been filed in the proceedings. So those are accessible on the CPUC website. And, I'll take an action item to provide a link to that from the EcoBlock website, because it can be a little daunting sometimes to find stuff.
Yeah, and we will send out links. If you want to provide us some links, we follow up with everybody here and everyone who's registered with this video. And I hadn't said that yet. So we will be sending out this video to everyone, and we can provide as many links as you'd be willing to provide us that help people along. Rosalind, are there any more questions in the chat? I'm trying to there's been a lot of talk about classes. So I like that about classes people can take.
Wonderful. That's so great. And I haven't had a chance to follow in the chat window, but I'm really happy that conversation is going on.
Yeah. Okay. So
looks like Ichiku has a hand up again.
I'm so sorry. If there are questions in the chat, I'm happy to wait and make space for other people.
Go ahead, we're monitoring.
I was going to ask what your research interests are, because this seems to be a project that sort of you have expertise in and you're drawing expertise from, but what does your group study in terms of interests.
So right. So this project is a labor of love, I think, for a lot of us, because it's just something that feels like, you know, we're doing good. It feels like we're at least trying something that's really needed in the world. In terms of you know, my academic sort of engineering research, it intersects with this in the area of how do you control distributed resources. We've also done work, my group has done work on electric measurements. And we've asked the question, if you have really precise measurements of, you know, electric voltages and currents in the distribution system, where historically there's not been much visibility of what goes on, how can that help integrate more solar power? There have been many places where, you know, and I'm thinking about Hawaii, where they had to say, oh, the grid is full. Well, you know, you can't connect any more solar. We're having voltage problems. And how do you address that with intelligent control and by sort of working with very precise measurements? So there's a thing called a micro PMU, or micro phasor measurement unit, that my colleague Alex McEachern built, and we developed with an ARPA-E funded project, which is now out there in the world being used commercially by electric utilities to basically help them with solar integration. There's work also on data analysis. First of all, the database, there's the Berkeley Tree database, another amazing open source product that has come from UC Berkeley, and other really other software that helps manage resources and sort of deal with large volumes of data very quickly, because we're good at doing this. It's not been a feature of traditional electric grids to intersect a lot with information technology. So, you know, I would say my sort of engineering passion would be in the area of sort of understanding how much we can, how much wisdom we can extract from high precision measurements.
That's very cool. Thank you so much.
Thank you.
Thank you for that great question and answer. It looks like we did have one more question from the chat, and then we can go ahead and close out for the evening. Someone was wondering if you can give us a rough idea of the cost per dwelling unit for subsequent EcoBlocks.
If I knew a number that I felt confident about, I would tell you, but let's get some more data before you quote me on that and put it on YouTube.
Sounds good. Well, I just wanted to take a moment to wrap up for the evening and thank Sascha again for her fabulous presentation and sharing with us more about the Oakland EcoBlock. If you did want to learn more about the project, you can actually visit their website at ecoblock.berkeley.edu. And you can visit our website at science@cal.berkeley.edu to check out some more of our events and programs coming up. Thank you all so much for being here and for participating with your great questions. And thank you again to Sascha. And have a great night, everyone. We'll see you at our next lecture.
Thank you. Bye-bye.
Thank you, everyone.